Okay, so reinforcement learning is having a moment right now. So what exactly is reinforcement learning? Well, basically it's a way of improving a model by giving it pats on the head when it's good and slaps on the wrist when it's bad. And this was, for years, it was really cutting edge. And then it kind of fell out of fashion with the development of transformers and so on and generative models. But back in the early days, you would find it in, for example, recommendation agents. So you would have, say, the Amazon recommendation system. If the AI said, okay, you might want to buy this product, and you bought it, then the model got a reward for that. If it's just something and you didn't buy it, then the model didn't get a reward. And some of these were really great. I have my own story about this. I mean, there's a lot of stories about, say, Amazon predicting people were pregnant before they knew and stuff like that. When I was in college, one of my classmates got outed as a spy. For the whole next week, LinkedIn kept recommending people to me who were legitimately spies. So their algorithm was really great. So then that was very much kind of reinforcement in the wild, happening with real human interactions. And then when Transformers came in, it had to become a lot more top-down and coordinated. So you have OpenAI, whose reinforcement learning is done by these sort of whole warehouses full of guys in Kenya who grade answers, for example. But over the past few months, people have kind of returned to reinforcement learning as a way to compensate for the lack of new high-quality data, especially superhuman data, when it comes to training. So what people are saying right now, and what I've been saying since 2020, but who's counting? If you give an AI a task that has a clear numerical gradable output, so either pass or fail, or it's trying to write code that either compiles or doesn't compile, or it's trying to trade crypto like our AIs. The AI or a system that is attached to the AI can automatically grade that and give it a reinforcement learning mark, either pat on the head or slap on the wrist, depending on how well it did, without a human in the loop. And that's really interesting because it opens up the way to artificial superintelligence. So there's a few people working on this right now. There are some people at DeepSeek are doing it. There's a guy who brought out a paper that was very similar to one of the earlier papers on this, which was Schminchuber's PowerPlay, which came out in 2013. But obviously this new one is kind of more advanced, where he gets the AI to try and solve maths problems, and then that gets checked by a proof checker, and if it's right, we retrain the model on the results it got right. There's another one that just came out from, I think it's a Chinese group of researchers, and they were again trying to get the AI to write code that runs or compiles. The problem with this is if you're doing it in this very, I would say, again, curated, self-contained environment, there's a risk that you're getting the AI to just learn stuff for the sake of learning stuff. It's not learning stuff that is necessarily super useful. So with the Superior Agents product, what we want to do is get the AI doing this in real-world context, trading perps. Either it's a good trade or it's a bad trade, and the AI can't argue with the results. We can retrain the AI on real-world data, which has two advantages. First, it's new knowledge generated purely by the AI with no humans, so that is a big deal. And secondly, it's high-entropy data because it's coming from real-world interactions, not these kind of set-up game interactions that kind of tend to be a bit contrived, I would say. Which is not to say the papers are bad. I want to go further. I want to do this in the real world, not in a simulated world.